Hi guys, welcome to the first part in this video series on low-level programs control flow theory. And in this series I'd like to share my own understanding of what's going on while the program execution at the lowest level. And in order to get what am I talking about, you could have just imagined that you have just written some simple program in a high-level language, no matter what particular language it is. So say you have written something if the value of the given variable is equal to, say, 10, then execute this piece of code and do something there. Otherwise, execute another piece of code. And we are so used to this constructs of high-level programming languages that quite often it happens that we don't really understand what particularly happens at the lower level. And if we just take the CPU or the central processing unit, just in other easy words, if we take our processor, that it basically doesn't have any idea about your program, and everything it actually cares about is the particular instruction to execute. So in a very simplified manner, we could have explained this as that the CPU takes an instruction as an input, then he processes it and gives some output. And the processor itself doesn't really know anything about what next instruction is it actually going to execute. And in order to have the list of instructions, or in other words, to have some program, we have to store the location of each particular instruction somewhere in the memory. And here comes the register that holds the address of the next instruction to execute, and it is called an instruction pointer. I've just said the word register, and that the register may be observed as a like a super global variable, but it is located not in the random access memory, but instead in the processor. So it's just like a little chip inside the processor. I don't know how it particularly looks like, but that's just my own understanding of what is it. And there are many different kinds of registers, and one of the registers we're going to talk about today is the one that is called the instruction pointer. And the purpose of this register, as I already said, is to tell the processor the address, where is the address of the next instruction to execute. So the processor is going to execute just the exact instruction that is stored at the instruction pointer register at this very particular moment. So bearing this in mind, we will go further. So let's imagine some memory map, yeah. And so say this are the physical addresses in the random access memory, and well, at this particular scheme, we actually assume that the size of each particular instruction is only 1 byte. In the real life, it's not really like so. There exist 1 byte instructions, but most of them probably are 2 bytes long. But just for the simplification and for some educational purposes of understanding the material, let's assume that each instruction is only 1 byte long for now. So we have a physical memory location and the instruction that is stored there, and we have another next location, and each location has the next instruction to execute. And this is this might be observed as a kind of an array of instructions, or in other words, it's just a list of instructions. And here I represent absolutely the same instruction set, but in a different, visualizing this a bit differently. So we have the instruction, and we always assume that it is stored at the particular address. And this is very important, because when we are writing in assembly language, then the program usually has well, the assembly program is basically some sort of list of the instructions to be processed. And here we come to the very main part of this video, is actually the control flow. So the natural way of processing the instructions is just one by one. So we process the first instruction, and then we go to the second, to the third, and so on until we get to the last instruction. And after the last instruction has been executed, the program exits. Well, if it's written correctly, of course. So and now, what's the point to have the instruction pointer? Say we always know that the instructions are executed, but it's not well, sometimes we do not really want to execute instructions one by one. So in that case, there would be some instructions that would adjust the particular address stored at the instruction pointer, but this is the topic for the next videos. But but in this video, the last thing I'd like to say is actually I'd like to illustrate the program flow visually. So say we have say we have a value of 0 at the instruction pointer. So just imagine somewhere in the processor there is a chunk of bits. Well, usually it might be 32 or 64 bits, and it stores some number, and this number is the address in the physical memory. So if the instruction pointer has the value of 0, and at the value of 0 the instruction 1 is already been initialized, so we assume that the program has been already loaded into memory. We're not really going to talk about how exactly this happened, so let's just assume that the instructions or the instruction list or the program is already at the memory. So in this case we start at the location 0. So by inserting this particular address, I'm showing where the instruction pointer is pointing at. So at the very beginning of the program, the instruction pointer is pointing to the location of the very first instruction to execute. And then this first instruction is taken by the CPU as an input and being processed, and the CPU gave an output. And then the instruction pointer is increased, and the next cycle the instruction pointer is pointing at the next location in the memory. So now the instruction 2 is the input for the processor, and it has been executed either. And then the instruction pointer points to the next, and to the next, and to the next, and to the next, until the last instruction. So please try to understand what I've just said, because this is very important. When the next video we are going to start talking about the go-to instruction, or maybe it sometimes is called jump instruction, so no matter how you call it. And the reason for using the go-to, say if we are now if the instruction pointer is now pointing, say, here, then if the instruction 1, say, is a go-to instruction, and this instruction would adjust the instruction pointer's address somehow, and say after executing this instruction the value at the instruction pointer might be, say, 6. But this is the topic of the next video, so until the next video guys, see you.